Great. And now let us go with solving quadratic equations not written in standard form. Example number 1. Find the roots of x times the quantity of x plus 4 equals negative 3. Our first step to solve this equation is to use distributive property of multiplication, wherein we need to distribute x in the terms inside the parentheses. So we have x times x, that is x squared. Then x times positive 4 is positive 4x equals negative 3. Then we will rewrite the equation in standard form by using addition property of equality. So we have now x squared plus 4x plus 3 equals 0. Then after that, we have to factor out this trinomial in the left side of the equation. So we have get the factors such as x plus 3 and x plus 1 equals 0. So how did we get this? The factors of x squared are x and x, while the factors of the last term, which is positive 3, are positive 3 and positive 1. Therefore, if we will add positive 3 and positive 1, we will get positive 4 in the middle term. Then, after that, we will use zero product property, wherein we will equate the factors to 0. So we have x plus 3 equals 0, and the other one is x plus 1 equals 0. Then we will be using addition property of equality once again to solve for the x. Therefore, we have x equals negative 3. And the other one is x equals negative 1. This means that the roots are negative 3 and negative 1. To check if our answers are correct, we have these solutions. For x, which is equal to negative 3, we have negative 3 times the quantity of negative 3 plus 4 equals negative 3. We simply substitute negative 3 to all x's in the equation. That's why we came up with this equation. Now, to simplify this, we have negative 3 times 1 because negative 3 plus positive 4 is positive 1 equals negative 3. Therefore, we have negative 3 equals negative 3, which means our first solution is correct. For x equals negative 1, we have negative 1 times the quantity of negative 1 plus 4 equals negative 3. Then, we simplify it. So we have negative 1 times the sum of negative 1 and 4 is 3 equals negative 3. Therefore, we have negative 3 equals negative 3. This means that the second solution is also correct. Question. Great. Next example. Find the roots of the equation 5x squared minus 12 equals 2x squared plus 3. Again, we have to write first the equation in standard form. So from this given equation, we have now the equation which is 5x squared minus 2x squared minus 12 minus 3 equals 0. So we transpose all of these terms from this side going to another side. So this is now the result. Next, express the equation in the form x squared equals c, then use extracting the square root method. So from this equation, which is 3x squared minus 15 equals 0, it will become now 3x squared equals 15. Then we will use multiplication property of equality, wherein we need to multiply both sides of the equation by 1/3. And that gives us x squared equals 5. Why? Because 3x squared times 1 is 3x squared over 3 is x squared. Then 15 times 1 is 15 divided by 3 is 5. That's why we have x squared equals 5. So the square root of x squared is x equals positive or negative square root of 5. We still copy square root of 5 because 5 is not a perfect square. So therefore, the roots are positive square root of 5 and negative square root of 5. Questions? None. Now, let us go with the third example. Find the roots of the equation square of x plus 1 plus the square of x minus 2 equals 10. In this case, our first step is to get the square of the binomials. So the square of x plus 1 is x squared plus 2x plus 1 plus the square of x minus 2 is x squared minus 4x plus 4 equals 10. After that, we have to combine similar terms. So we have to arrange the terms from quadratic term going to linear term and to the constant terms. So we have now x squared plus x squared plus 2x minus 4x plus 1 plus 4 minus 10 equals 0. Then we have to find now the roots because our new equation is now 2x squared because x squared plus x squared is 2x squared. Then the difference of 2x and 4x is negative 2x. Then 1 plus 4 is 5. Then 5 minus 10 is negative 5 equals 0. Now we will be using the quadratic formula to find the roots of the quadratic equation. Now the first step to find the roots of the quadratic equation using the quadratic formula is to identify the values of a, b, and c. So based in the equation, our a is positive 2 because the numerical coefficient of the first term is 2. Our b is negative 2 because the numerical coefficient of the second term is negative 2. And c is equal to negative 5 because negative 5 is our constant term. Now, again, our formula for the quadratic equation is x equals negative b plus minus square root of b squared minus 4ac all over 2a. So, let us substitute the values of a, b, and c to it. So, we have now x equals negative times negative 2 plus minus square root of the value of b, which is negative 2 squared minus 4 times the value of a, which is 2, times the value of c, which is negative 5, all over 2 times the value of a, which is 2. Then, simplify the equation. So, we have 2 because negative times negative 2 is positive 2, plus or minus the square of negative 2 is 4, plus the product of negative 4, 2, and negative 5 is positive 40 all over the product of 2 and 2 is 4 equals 2 plus or minus square root of 44 because the sum of 4 and 40 is 44 all over 4 equals 2 plus or minus square root of 4 times 11 because 44 is not a perfect square. So we got or we need to get the factors of 44 where one factor of it is a perfect square. So 4 here is the perfect square. And to simplify the equation, we have 2 plus or minus 2 square root of 11 all over 4. Our 2 here is the square root of 4. Then, after that, we have to reduce the terms of the equation to the lowest terms by dividing both numerator and denominator by 2. So, therefore, we have 2 divided by 2, which is equal to 1, plus or minus 2 divided by 2 is 1, square root of 11, or square root of 11, all over 4 divided by 2 is 2. Therefore, we have the roots such as 1 plus square root of 11 all over 2 and 1 minus square root of 11 all over 2. That's it, and you may now start answering your module.